Assessment of strength and quality of concrete reinforced with different types of steel fibers. Abstract. The reports of the past investigations have vividly expressed the significance of steel fibers and its contributions in enhancing the performance of concrete. The paper aims at investigating the most efficient and potential steel fiber among all four, i.e. hooked, crimped, twisted, and straight, that contributes in boosting the performance and quality of concrete after extensive examinations. Several concrete mixes were examined, incorporated with fly ash, Fa, and metakaoline, Mk, in various. Each composition is reinforced with four types of steel fibers in varying fractions of 0%, 0.5%, 1%, and 1.5% to examine the potential of steel fibers in enhancing the properties of concrete for 28 days and 56 days curing period. After exclusive experimentations, it was finally confirmed that hook steel fibers composite concrete mixes contributed the best performance among all other types of steel fibers, whereas straight steel fibers showed a minimal performance compared to other steel fibers. Keywords: compressive strength, flexural strength, porosity, ultrasonic pulse velocity tests, steel fibers, fly ash, metakaoline. Introduction. Concrete forms the most prominent building element in the field of construction industry that has been in use since decades. A lot of efforts have been made to discover the durable and serviceable concrete strong enough to sustain all adverse climatic conditions. Investigations are in progress to develop the sustainable and eco-friendly concrete by modifying with industrial waste materials such as fly ash, silica fume, GGBS etc. that plays a key role in boosting the strength properties of concrete. Fly ash constitutes the major waste material that is obtained as a residue during the process of incomplete combustion of coal from thermal power stations. Past investigations proved that the replacement of cement with fly ash in concrete greatly improves the strength and durability of concrete. Metakaoline, nowadays, forms the major pozzolanic material, that is obtained as a byproduct from the calcination process of clay mineral kaolin. It was been in use as a partial substitution of cement in concrete to examine the variations in the behavior of concrete, and it was evident from the previous studies that it significantly influences the strength of concrete owing to its fineness property. Steel fibers are utilized as an additive component in the mix to strengthen the compressive and flexural characteristics of concrete. There are various forms of steel fibers such as hook steel fibers, crimped, straight, twisted, deformed, intended steel fibers categorized based on its configuration. That has been in use in concrete since decades that highly influenced the properties of concrete. Presently, four types of steel fibers, i.e. hooked, crimped, straight and twisted steel fibers are included in every composition of concrete incorporated by fly ash and metakaoline to investigate the impact of steel fibers on the behavior of concrete, which is supported by several past researches discussed briefly. Literature review. Minhajuddin, 2019, investigated on the effect of inclusion of hooked and crimped steel fibers on the fresh and hardened properties of self-compacting concrete. The results demonstrated that compressive, flexural, and impact resistance improved significantly with the combined mix of steel fibers. Untitled, 2020, examined the tensile behavior of concrete by introducing corrosion-straight steel fibers in various proportions in concrete mix. It was found that corrosion steel fibers enhanced tensile strength by 4 to 6% without any deterioration of the bond resistance. IJERT, 2019, presented the computational model to observe the impact of twisted fiber on the pull-out force and frictional behavior. The simulations revealed that maximum pull-out force and energy dissipation capacity increased with the decrease in the pitch of the fiber twist. Untitled, 2019, experimented on the utilization of different types of steel fibers in ultra-high-performance concrete to evaluate the potential of each fiber under extreme loading conditions. Results proved that straight or moderately deformed fibers perform well under extreme loading conditions than hooked and twisted steel fibers. Larson et al., 2020, discussed upon the influence of steel fibers inclusion on compressive and tensile behavior of ultra-high performance concrete and resulted that steel fibers exhibits major contributions in increase in tensile strength, but improvement of compressive strength varies with the geometry of test specimens and other factors. Materials used. Cement. Cement is the major component in the manufacturing process of concrete. It has the property to stick to any other raw material added in the preparation process of concrete, especially when comes in contact with water, and hence produces a good paste. Here, OPC 53 grade cement is used, whose properties are shown below. Fine aggregate. Fine aggregate is first graded to decide the zone to which it belongs to. Generally, there are 4 categories of fine aggregate: Zone I, Zone 2, Zone 3 and Zone 4. In this work, sand of Zone 2 is chosen, whose properties were given below. Generally, fine aggregate is passed through 4.75 mm sieve. Coarse aggregate. Coarse aggregate is another fundamental raw material which gives strength, hardness, and increases the volume of the concrete. Here, coarse aggregate of size 20 mm and angular crushed shape is chosen. Fly ash. Fly ash is widely produced waste material across the globe. Steel fibers. Metakaoline. And it constitutes the major industrial waste throughout, coming out from thermal power stations in the process of combustion of coal. Based on its chemical composition, it is categorized into 2 types: Class C and Class F. Class C fly ash is highly reactive due to the presence of high content of calcium, whereas Class F is slightly inert owing to its less calcium content. 4 types of steel fibers are introduced in our present work, which are hooked, crimped, straight and twisted steel fibers, which are prepared from the mild steel drawn wires. All fibers are collected from IJERT enterprises located in Rajainpur, Odisha, and are ensured to maintain the same aspect ratio of 50 with 30 mm length and 0.5 mm diameter, with the tensile strength of 1100 MPa and specific gravity 7.8. Admixture. Superplasticizer Compost SP430 is used for casting of concrete samples. It is made of sulfonate naphthalene polymer, specified as per IS 9103 to 979, that achieves in reducing the water content by 20%. Water. Normal tap water is utilized in the present work in the preparation of concrete specimens. 5. Metakaoline. Class F fly ash. Results and discussions. Compressive strength results. For 28 days curing period. Tests were performed on all the concrete compositions reinforced with 4 types of steel fibers, i.e. hook, crimped, straight and twisted steel fibers, to evaluate the compressive strength results after curing for 28 days. The results are: metakaoline has gained tremendous significance in the construction industry due to pozzolanic characteristics. The calcination process of kaolinite, china clay, results in the formation of highly pozzolanic reactive raw material metakaoline. Metakaoline, being finer in size and reactive in nature, fills up the void spaces in concrete that improves the mechanical properties of concrete to a huge extent. Presented in brief in the table below. Flexural strength results. For 28 days curing period. Concrete prisms with different compositions of Fa and Mk reinforced with 4 types of steel fibers are tested for flexural strength as per IS 516-1959. The results obtained are shown clearly below for all compositions for 28 curing period. Porosity studies. Porosity is one such property that affects the durability properties of concrete, such as water permeability, rapid chloride permeability, angrazine of chlorine ions, etc. Concrete specimens after curing for 28 days are subjected to 105C heat curing for 2 days. Porosity is determined by evaluating the percentage loss of weight of the specimens after heat curing at a temperature of 105C. The porosity values for all mixed compositions are shown clearly below. Ultrasonic pulse velocity results. Ultrasonic pulse velocity tests are performed to detect the quality of the concrete by computing the time taken by ultrasonic pulse waves to pass through the concrete. As per ASTM C597, concrete specimens are categorized into excellent, good, doubtful, and poor for UPV values of 4.5 km per second and above, 3.5 to 4.5 km per second, 3.0 to 2.0 km per second and below 2.0 km per second respectively. UPV values for all the compositions are shown below. V. Conclusions. Following conclusions were extracted from the results and discussions obtained. All compositions with hook steel fibers showed extremely good compressive performance, followed by crimped, twisted, and straight steel fibers respectively. Highest compressive strength of 57.52 N/mm2 is achieved by a composition of Fa45% plus Mk13.5% with 1% hook steel fibers among all other compositions for 28 days curing. Highest compressive strength of 67.42 N/mm2 is achieved by a composition of Fa45% plus Mk13.5% with 1% hook steel fibers among all other compositions for 56 days curing. Excellent flexural performance was exhibited by all concrete mixes reinforced with hook steel fibers, followed by crimped, twisted, and straight steel fibers respectively. A mix of Fa45% plus Mk13.5% included with 1.5% hook steel fibers yielded maximum flexural strength of 7.34 N/mm2 and 7.99 N/mm2 for 28 and 56 days curing respectively among all other mixes. Concrete mixes hybridized by Fa and Mk, especially strengthened by hook steel fibers, exhibited least porosity values, followed by crimped, twisted, and straight steel fibers respectively. Concrete mix hybridized by Fa45% plus Mk13.5% with 0% hook steel fibers yielded the least porosity value of 6.48% among all mix proportions. All concrete mixes incorporated with hook steel fibers falls under the category of excellent quality determined as per ultrasonic pulse velocity test. This signifies that all these mixes are having fewer voids than other mixes. A combined replacement level of Fa45% plus Mk13.5% performed significantly better compared to other combinations of Fa and Mk. Inclusion of hook steel fibers in concrete compositions contributed excellent overall performance and proved to be the most efficient fiber among all fibers. Straight steel fibers exhibited least performance in terms of compressive, flexural, porosity and quality among all other fibers.